分了，包包乱放，桌上乱放，门随便什么样关着，毛病没一个改的，怎么样方便怎么样来。
All right, pretty good. Yeah, today's quiz is a little bit longer because it's going to be serving as a comprehensive review. Anyhow, this is so we only have two classes left, including this one. Today, I hope you can all see my screen, right? We will talk about an important topic in software engineering, which is testing, very important, and debugging. So, in the normal programming life, you would hope that all your program will run after you first wrote it. It's like what this girl's bike is. It parked just in place. That's what you want the program to do. However, in reality, especially for first programmers, your program actually does this, right? It failed at the first try. This is normal life. So as a programmer, you need to constantly be able to debug and solving test your code. So let's talk about testing. I'm drawing an analogy of testing with making a soup, right? You're making a soup, but the ladybugs keep falling from the ceiling. That's what's analogy to your program has bugs. What do you do? Well, you can check soap for bugs. That's called testing. And you can keep the lid closed. That's called defensive programming. So you can, keep the bugs outside your code. Or better yet, you can clean the kitchen. You limit the source of bugs. That's what we call debugging. Defensive programming requires you employ some basic principle while writing a program, right? For example, function is the common unit of your program. You write specifications to the function. You check conditions in inputs and outputs, especially for user input, right? You want to, sort about all kinds of weird input. Okay. So you compare the input and output pairs to your specification and think about if that makes sense, why some input breaks your program. In debugging, you also study the events that lead up to an error, right? How can I fix my program? Okay. So in the good programming case, you want to set yourself in a position so that you can easily test or debug your code. So the word of wisdom is not to write all the entire code all at once and print and then run it and realize, oh, I have a bug in it or maybe a couple bugs in it. Instead, write a couple lines of code or maybe a small function and just starting to test it. Once this is done, test it, check it off, and build more, right? So you want to break your program into modules that can be tested and debugged individually, a good practice. And you want to document your constraints on modules. What do you expect input to be? What's output, right? And also document the assumption behind the code design. When are you ready for testing? So when you finish writing your program, first thing you want to check for syntax errors, remove semantic errors, and the Python interpreter can help you with that, right? If you have those kind of errors, Python can capture that. You also want to have a set of expected test samples and results so you can compare them. Okay, now let's talk about different classes of tests. We have a unit testing, which is validate each piece of program and test each function separately. Let's take a look at the example here. So remember, when we talk about function, we talk about example of writing a function for a circle, area of a circle. And here is the simple function you implemented. Oh, a junior engineer coming, hey, I can write a function for calculate the area of a circle. That's pi times r squared. Done, right? Well, a test engineer come in and say, okay, let's test this. I'm going to provide the radius of various sizes. There's 2, 0, -3, 2 plus 3j, which is a complex number. Oh my God, he also tested with a Boolean value and a string. Okay, now what? You will quickly find out this is not a defensive coding. You will soon encounter the error very soon, right? Let's just test it out. You can see there's negative numbers and not a number at all. How do you program defensively? Okay, so that's unit testing, right? You want to write a program that you just saw is testing your function. Okay, And also there's regression testing, which means you find a bug in your function, right? You catch the function, catch error by writing some test functions. And when you further develop your code, you want to rerun that test function, make sure that bug is not reintroduced into your code. That's called regression. So in other words, prevent the code from regress. And then finally, there's integration testing, because your code is probably a part of a bigger system. Once you check in your code, how do you, test the whole system with your new code in it to ensure that overall program will work? So that's integration testing. So you will conduct various different testing in your programming career. How do we approach testing or debugging? So whenever you have a function, you want to try a different boundary of the input, right? You want to check a smaller value, a bigger value, or miss something in the middle, or some illegal values in the parameters to make sure it's all handled properly. Okay, for example, in this function is bigger is comparing x and y and return which one is x is bigger than y. Can you come up with some testing cases for this function? Think about it, right? What are the natural partitions in the numbers x and y that you want to test with? Frank, if you were tested, what number of xy you want to test this function with? Pick some typical number.
I can just answer. Just like do like
Yeah, sure.
5 and 6.
So you want to pick in general, right? You want to pick a number as bigger than y, and less than y, or equal to y. The question was, Frank, if you want to test this function, is bigger xy, what kind of number of xy you want to plug in to test those functions? And Tristan just answered some of the examples. But to be more general, right? Two and one, yeah, and then there's more, right? You want to test with equal, right? If they are x equal to y or x less than y. So you want to test all cases, isn't it? You may want to test the different numbers, an integer, a float, or maybe. Now, if you write defense, yeah, okay, go ahead. Yeah. So there's a lot of different.
You
Good.
can also do negative, right?
Yes, negative numbers, very good. Or maybe all kinds of straight number. So there are also, when it comes to unit testing, there are two type of testing. What's it called? Black box. Black box means you don't know how this function is implemented. To you, it's like a black box. All you know is the interface, aka what is the input and what is expected output. So usually, if you are testing some code written by someone else, you want to do black box testing. So that's why it can be done by someone other than implementer or developer to avoid some developer bias, right? And you can reuse that test as long as you keep the interface, which is the input and output, the same. But you feel free to change the implementation. That's called black box testing. For example, this is a square root function. You want to test a perfect square, a number less than 1, irrational square root, and some extreme big small numbers. But all in all, you only test to the interfaces, not the implementations. As long as you implement the SQRT, I don't care how you implemented it, right? And then there's another testing called glass box testing, which you are testing directly to, you have the source code, right? You know how the code is implemented, Now you want to use that knowledge as an advantage to test it if there's branches. You want to test all branches in the code. If there's loops, you want to test the condition inside and outside the loop and when loop terminates, okay? So, for example, if I have this absolute value function, right? How do you test the function, see if there's a bug in it, right? Well, you may say, I want to test both if else. So let's put a number x that's less than -1, let's say -2. It will return 2, right? Minus 2 is 2. And that's correct. And I'm going to pick one that is, positive number like 1 or 0, and it will return 1 or 0. Looks like it's working, right? No. Because there's one number that make this function break. Which number is that? Can somebody tell? Yes,
this
sir.
is -1.
-1, correct. Because -1 is not less than -1, so it's going to be return -1, which shouldn't be there. So how do we fix this function, by the way?
You can either do like less than or equal to, or no, you could do like, yeah, less than or equal to, or just make another case.
Less or equal to, is that still -1 though?
No, you can do like,
It should be 0,
it's
right? Less than 0. Because you want to do a negative sign if it's a negative number, right? So x less than 0, correct?
Yeah.
Yeah. So once you find the bugs, you want to isolate it, you want to eliminate it, and then you want to retest until the code runs correctly, because there may be more than one bug. Okay, some fun history of computing. Nobody here, including me, your instructor, was born in 1947. Nobody, okay? But legend says that back then in 1947, the computer looks like this, okay? It's comprised of vacuum tubes and tapes, and then the entire computer occupies the entire floor. This is a Mark II icon relay computer. Admiral Grace Murray Hopper. She is one of the few women engineer working in the military. And one day in her lab report, they found that a computer is not working properly when calculating the trajectory of missile. And they find a relay number 70 on panel F. There is the moth in the relay that shorted the circuit of the relay. And that's why there is a bug. So it's the first actual case of a bug being found from a computer is actual bug. And hence, from then on, any computer errors that you discover is called a bug. All right. I also found a bug in my computer back then because it's so dusty. There is like cockroach being burned in my computer. All right. So bugs sometimes are very hard to find because your code may run no problem, once, and then sometimes it will crash, right? So it's intermittent. It's very difficult to debug those kind of things. And if it's consistent, then it's maybe easier. So overall, you want to accumulate debugging skills by just writing more code and step through the code. There's some technique we can talk about today. So you can use IDE, you can use a Python tutor to step one by one, and you can use print statement, right? The old good print statement. And yeah, where to put your print statement is also art. You can print when you enter the function and see if it's getting the result that you expected, or does that even invoke, right? If the function is not even called, you have a problem. And you can print the parameters of function, you can print the results returned by the function and see if it match your result. You can also use the bisection method where you print in the halfway in the code and determine where the bug may be depending on the values, right? Okay, there's some typical error message where you type in Python. You may have easily encountered index error where because the number is start with 0. So if you print test 4, it has auto boundary error because there's no such thing as index 4. It starts from 0. And also some conversion error. If you want to convert this list to integer, it's a type error. Or if you never if you never declared a variable and you reference to it, it has a name error. And also you can't mix the data type like string 3/4. Or sometimes you forgot to close the parenthesis, which is also a syntax error. Now, syntax error is obvious. Python can help you with that, but logical error is hard, right? And it requires you to think before writing the code, maybe draw a flow chart or pseudocode, draw the picture, take a break, or explain the code to someone else or robot.key. So once you explain the code to someone, you may find, oh, I made a mistake here because your brain is trying to recreate the logic that you had in mind. And by explaining the code line by line, you may be able to find the code, the bug. So here I will give you examples how to debug a code. You can treat it as a search problem. So here is the code. Let me. You all see the code, right? So in this code, there's two functions. One is called the silly, which is trying to get the user input, and it's trying to call the function isPaul, which stands for is a palindrome, and pass in the result, right, which is the input from the user, and it was supposed to print the yes or no, depends the result. So the is palindrome function will give you take the input of list of characters from the input string and return if this list of character is a palindrome or not. And you all know what the definition of palindrome, right? So that's how the code, what the code is doing. Now, I would say there's bugs in the code. Okay. Can you identify the bugs? Okay. Let's try to break down stepping through the test, right? So let's run it actually. Let's see if there is a code part. I can just show you. I'm gonna use the Python tutor to step through the code. You know what? I'm just copy it. Okay. I'm gonna do. Okay. Python. Oh. Is that right? Okay, so you can all see that I'm trying to run this and the result equal to, oh yes, this is, I need to indent this. Okay, let's run this. So a silly function, wait. Oh, you need to, the reason is nobody is calling this silly function. Right? It's called a silly function. Silly, um, let's say 2. Keep it simple. How about that? All right. So I'm going to call silly function 2. And for range 2, result equal to space. And we're going to input enter element. Let's enter A. So element is A. And then I'm going to run this. And I give the element B. Okay, so now we have element A and B. So element is B and print result. So I enter the 2 element A and B. I'm supposed to know AB is AB a palindrome. It should not be, right? Because AB is not equal to BA going forward and backwards. Palindrome is the string or number that it's the same if you spell forward and backwards, okay? But then it returns yes. It says AB is a palindrome. Of course, it's a bug, right? So can somebody tell me, first of all, what's wrong with this silly function? So if I enter A and B, what I'm supposed to see in that element? A list, right? I want to see both A and B, correct? Jacob?
Mm-hmm.
But I only see B. Why? Anything wrong that you want to investigate more? Which line that may be causing this to happen? So we're debugging this code, right? Where do we start? We found with Houston, we have a problem here. Anyone may point out where should we, because we have added a print statement here on line 14, which is halfway of this function. And clearly the result is not what we wanted. So the bugs must be existing somewhere before this, correct? That's the natural logic.
Yeah.
All right, so on line 10, 11, 12, 13, can somebody tell me? Oh, Jacob is jumping ahead. we are looking at the silly function right now. I'll come back to that later. We're talking about silly function. Anything wrong with the line 10, 11, 12, 13? Which line you think may be causing the problem? Come on, just 4 lines. So we have 5 students. Everybody just give me an answer. Just type in the chat. Which line do you think? Okay, the possible answer is 10, 11, 12, 13. That may be causing a problem. We have narrowed that bug down to only 4 lines of code. Line 11. Very good, Jacob. But why do you think line 11 is a problem? Hmm? Okay. The rest of you are quiet, right? I mean, a trick that I have when I was a student is I always ask question. I always try to answer teacher's question. This way I can test if I'm understanding it. By participating and thinking actively in the classroom, your brain is quickly helping you to understand material better, right? This is like a detective work. So I hope that give you some fun fact. Tristan, do you think line 11 is a culprit, and how to solve this?
Not quite sure.
All right, that's fine. Look harder. Evil. Where is the evil? Okay, so line 11 indeed is a problem. Okay. Nobody has spotted the error. What does line 11 do? Do you understand that line?
Yeah, makes a list. Oh,
What does that do?
makes a list.
The empty square bracket. What does that mean? Tanya. Is that correct? If not, please let me know how to correctly spell your name. If you have an English name, let me know too.
It's making a list.
You are breaking up. I cannot hear clearly. It's making what?
A list. It's setting the result and naming the result as a list.
Am I hearing it's clearing the result every time you go to the loop, right? It's clean. Whatever result was, it's after line 11 is going to be empty, right? Do you want to do that inside the loop?
No, you set it outside.
Yeah, you only do it once. Okay, that makes sense. So let's do it outside loop. All right, now let's run it. Hey, we found a bug. We solved the bug. Let's see. A and B. Okay, it should be give you AB, right? Yeah, indeed, I have AB now as input. Very good. Now let's, hey, this is good. Let's tell if AB is a palindrome. It should not be, right? It still print out, yes, AB is a palindrome. So now there's something wrong inside this function is palindrome. What do we do? Shall we print out in the middle, like print, maybe temp x is temp x, and then print temp. Reverse temp is temp. Okay, so we are printing these two statements. A, B. Okay, we're going to the function and the print x temp is AB and x is AB, right? And then reverse after that, I'm gonna see reverse temp is, it's not reversing the AB. That's the problem. Why it's not reversing the AB? I think Jacob, you had some comment earlier, right? Which line?
Yeah, it's line 5.
Because reverse is a function, you need this to close it. Okay, so we found another bug. Yeah, are we done? Do you think we solved the problem? We solved two bugs, right? Yeah, let's try it. Just when you think you finished the problem, reverse temp is BA. Yeah, it is inverse. Okay, although reverse temp is BA, temp is AB. However, it still think its temp is equal to X. Why? Why? The temp is reversed, but why X? Let's print X as well. We can't see the screen.
Oh, I can see it.
Okay. Okay, so what is the problem? So it looks like temp X is AB, the beginning, and after reverse, the reverse temp X is BA, BA. So not only temp is reversed, X is also reversed. From this diagram, you can see something fishy here, right? Tanya is writing a comment. I'm eager to hear what she said. Did you find another bug? I hope so. Tanya, what do you say? What is another problem?
I can't get in.
You cannot get in what? Getting
The
like
code.
no. This is just a share, right? It's just a screen share.
Yeah,
There's
but I
no
can't
link.
see the screen.
Oh, okay. Let me try share again. Can you see it now?
Okay, yeah, I can.
All right. So you can see that I entered AB and the temp before reverse is AB and AB, which is good. And then when I reverse the temp is reversed to BA, but X is also reversed to BA. Is that the bug, right? And can somebody tell me why? Can you tell me why is this happening?
Because we only wanted to reverse one of them.
Yeah, we only want to reverse temp, right? We want to get X to be the original value, which is AB. But when we reverse the temp on line 5, the X, let's go back, okay? So before we reverse is AB and BA, AB and AB, right? So temp and X all points to this list AB. But then when we just on line 5, when we reversed the temp become BA, but the X is also BA. You see these pointers, arrows, X and temp are all referencing to the same structure in the memory. So they are sharing this structure. No matter how you modified through one of the variables, the other will change because these two are aliasing. They are alias to the same structure. You understand now? How do we avoid those kind of aliasing problems? We want to create two separate copies, although the content is identical, right? We wanted them to be different. So we want it when we want this pointer points to something else. So let's try. Does anybody have some idea before I review the answer?
Maybe like change line 3.
So doing the copy, you can do maybe x dot copy, right? So, or you can just do this like comprehension. So basically it's like making a copy of every data without the aliasing. Let's try it quickly so you see what's going on. Here you go. X, AB, no problem. And then temp Now it's making a copy to another list, which is also AB, but they are two separate lists, right? By doing this, you're making a copy of a array and copy every single element from X to the temp instead of just aliasing the temp to the same array. So now when you reverse the temp, look at that. Temp is reversed, but X is stay the same because they are two different things. And then indeed, at the end, it prints no. They are not palindrome because AB is not equal to BA. All right, so we have found how many bugs
Oh,
in
3.
this code? 3. And the last one is tricky, right? But the first 2 is just simple syntax error and initialize outside the loop instead of inside. These are common mistakes. So lesson learned. We will not only want to be good at debugging, but also once you find one bug, don't assume success until you test it again and then nothing break again. All right, I think that's all for today's new material. I do have a project for you, which we promised at the beginning of the semester, which is the text-based game. So you will see I have assigned you the project, okay? The instruction is here. You can see in the Google Classroom. You work for a small company, creates text-based games. You have been asked to pitch an idea to your team for a text-based adventure game with the theme and environment of your choice. Your game must include different rooms, items, and a villain. The basic gameplay will require the player to move between different rooms to gather all the items. A player wins the game by collecting all the items before encountering the villain. The player will have 2 options to command in the game, either moving to a different room by direction and getting an item from the room they are in. Movement between the rooms happens in 4 simple directions like east, north, south, and west. And read through the rest of the specs. It's long, but it's worth it. And your first task of the project is to design it. So use the PPT template to write a simple story of what thing you're gonna do, and also design a game room by using this, or you can use your own. So this is an example of the game room. You want to name it differently, and each game room has a direction to other rooms. You want to place where villains in and what item you put in each room, and make it a theme, right? Either Christmas or escape room or ghost, whatever Halloween theme. It's your choice. So yeah, go ahead and design this, write up some story about your game settings. And then the phase 2 will be, let's design it and code it. Okay, any questions? Yeah, this is nothing related to coding. It's just your ability to imagine. Imagine. All right, so we'll see you on Monday. Monday is our last class, and I hope you can. We're gonna do some review some key concept, and also we'll teach you some new concepts like classes. I know it's kind of, the class is a different paradigm, so maybe difficult at beginning, but after you code this game, you can think about how to use object-oriented programming to recode this game, right? We're gonna use double dictionaries for this main map and code it. So you already have all the tools and knowledge to code this game, believe it or not, right? It's a short 8 weeks, I guess. No, like 10 classes. But you already need know a lot of enough to become dangerous. Okay. Yeah. Any questions? At the end, you can also select your own game to implement, right? But it's just fun to see how this works out. Any question? I want to show you some like Python games, like first-person shooting game, 2D games. Depends on if I can find it in the next minute. Now that I can show you next class, give you some incentive, like what Python can do, right? It's really, really fun. But while I'm looking for the code, do you have any questions? What is this game? Okay. So this is one of the sample code for the text-based game. So let me show you how this works, right? So you start the game and you are prompted with some game, saying like collect all items, enter Chris' room, and defeat the evil monkey. And you are in the family room. Enter your move. You can either do like east. Oh, I encountered the evil monkey without all items. Game over. I'm so unlucky, right? Because I don't know the map. Yeah, let me try it again. Maybe this time I go to west. What? I encountered how many evils are there? But you get the idea, right? North. That's not right. Go north. Maybe you need a. Okay. Oh, forward, left, right. Don't do those things. Okay, let's do a left. What? Go left. Okay, here you go. You move to the steward's room. You are in the room image. You see a teddy bear. Let's say pick maybe teddy bear. There is a bug in it, but you see a good game will give you. Oh, it has instruction. Go left and get. Okay, let me try it again. Sorry, I didn't read the instruction. My bad. Go forward and then see and get Meg's hat. Okay. So you get Meg's hat. Here you go. Wait, get Meg's hat. You can't get Meg's hat. Why? Anyway, so it has some user convenience here. So when you design your own game, make sure that you don't let frustrate the user, right? So this is not a good example, but again, it shows you bad examples to avoid. All right, I think that's it for today. Hopefully you're having fun with Python and make it dangerous. I'll see you next Monday. Have a good weekend.
Bye.
Bye.
Bye.